This example involves summation notation. We have the summation of I equals 1 up to 15 of negative 2 to the ith power. Now if you look at this, we're going to have 15 terms that we're going to have to add together, again because I is beginning at 1 and terminating at 15. So again, we just might take a quick look at the first few terms. A sub 1 is going to be negative 2 in this case to the first power, which gives us a negative 2. A sub 2 will give us negative 2 to the second power, which gives us a positive 4. Note a negative base to an even power. A sub 3 will give us negative 2 to the third power, which from that we obtain a negative 8. Now note the difference here. To get from 2 to 4, we're multiplying here by a negative 2. To get from 4 to negative 8, we're multiplying by a negative 2, and by definition this is a geometric sequence. So rather than adding up all 15 of these terms, we can use our sum formula for a geometric sequence given to us as S of n is equal to a sub 1 times 1 minus r, that's our common ratio, to the nth power, all over 1 minus r. So we're looking for S of 15 here, the sum of the first 15 terms. A sub 1 is our first term, which we already have, negative 2, times 1 minus r. Here we need to find our common ratio, and the way we can go about finding our common ratio is take a sub 2 divided by a sub 1, a sub 3 divided by a sub 2, so on and so forth. Take any two successive terms and divide them, and in this case we can see that 4 divided by a negative 2 will give us that common ratio of a negative 2, and that's almost always represented as r. So we'll take that now and plug it into our formulas. You're going to want to use parentheses here. We got our negative 2, again to the 15th power, all over 1 minus a negative 2. So this gets kind of messy. You have to be careful in writing this out. We come up with something like negative 2 times 1 plus, in this case, since we have a negative base to an odd power, is going to be negative, minus a negative will give us that plus 32,768 all over 3. So let's clean this up here. The sum of the first 15 terms of our geometric sequence will give us a value of negative 21,846. And it's a nice use of that formula.